already seen many different kinds of expressions which contained exponents, squares and cubes and powers of 6 and 7, and even powers like 1/2 and 5/3. It may surprise you to notice that not one of those expressions contained an equal sign. Not one was an equation. On the other hand, we have seen lots of equations, complete statements with equal signs, but not one of them contained a variable with an exponent higher than 1. Every x was just x, and y was just y. There was no x squared or 3y squared or anything like that. They were all linear or first-degree equations. Now we're going to change that. We're going to look at some equations with squares in them, quadratic equations, and we're going to learn several different ways to solve them. We'll also hang on to the things we already know, of course. We still need all the techniques we learned with linear equations. And you may want to review some of the modules where we saw those techniques. But now we'll be using them on quadratic equations, degree 2, where the variable is squared. The exponent is a 2. Quadratic equations are not completely new to you. You can probably solve this one in just a second or two. Except that you might not notice that it has 2 solutions, both of them correct. That usually happens in quadratic equations, but not always. Let's see if the same thing happens in this one. It's a little bit harder, but not much. Just as you would expect, we start by dividing both sides by 2, the same thing we did in linear equations. And if x squared equals 5, then obviously x equals the square root of 5, because the square root of 5 is the number which, multiplied by itself, gives us 5. That's the definition of a square root, after all. But what are we overlooking here? We're overlooking the other number which, multiplied by itself, gives 5. What is it? The negative square root of 5. Remember, negative times negative gives a positive answer, so we still have 2 solutions, one positive, the other negative. Now take a look at this one on your own. Start by moving the 18 to the other side of the equation, and then finish up as we did in the last problem. First, I add 18 to both sides, and then I divide both sides by 3. That tells me that x squared equals 6. So I'll have to take the square root of both sides, and my answer, or rather my 2 answers, will be x equals the square root of 6 in either its positive or negative form. Have we solved a quadratic equation? Yes, we've solved several of them, but they were all of one kind, the kind that has x squared and a number, and no other x term. Actually, this method also works quite well on some equations that aren't as simple as those we've just solved. Say you look at an equation like this. You say, I can factor the left side into x plus 2 squared. Right. And then you can take the square root of both sides, which will free up that x for you. So you can go on to solve it as a linear equation. Notice that you still get 2 answers because the square root of 7 can be positive or negative. Try a problem on your own now. your answer when... To start with, I want that number term on the other side, so I move it. And then I take square roots on both sides and get my two answers on the right, plus and minus. Move the 7 from left to right, and I'm finished. So that's how we solve equations that have something squared and a number. But there are lots of other kinds of quadratic equations, and we'll use 3 other methods to solve them. We'll look at the first of them, factoring, right now. The first thing you want to do here is recognize your old friend on the left. It's a trinomial which you can factor pretty easily into 2 expressions. And there you stop. What did that accomplish? Not a thing, until you think very seriously about one special property of numbers that goes like this. If a product of 2 real numbers is 0, then at least one of the 2 numbers must also be 0. That's a fancy way of saying that you can't get a 0 product unless you multiply by 0. Pretty obvious. Now, where were we on that problem? The product of x minus 3 and x minus 2 equals 0. What does that mean? We just said it. Either x minus 3 is 0 or x minus 2 is 0, because at least one of them has to be 0. Suddenly we have 2 very simple linear equations, and at least one of them has to be true. Our 2 answers to the original equation are 3 and 2. So we go back and look at that equation because we can use it now to check each of our answers. 3 first. We substitute, and it works. What about 2? It also works, and we have 2 correct solutions to our original equation. But notice once again that our method required a certain kind of equation, a trinomial that factors out, and a 0 on the other side. Now you may think you're about to get one of these to do on your own, but you're wrong for a change. We have to do one more together first. It's a quadratic equation with an x term, so we have to try to factor it. But we can't do that with the 4 on the wrong side. And besides, we're lacking our 0. But we take care of both at once by moving the 4. Now we can factor and come up with exactly what we want. 2 expressions which, multiplied together, equal 0. That means, of course, that at least one of the 2 factors is equal to 0. Each now has the form of a linear equation, so we solve the first and get 1/2 for an answer. We solve the second, and our answer is a -4/3. Which one is right? They both are, which you can prove by substitution if you have the time. Otherwise, take my word for it. Factoring is a rather tidy way to solve quadratic equations. But it doesn't always work, because they don't always factor. We'll see what to do about that in another module. Right now, you may want to look up more information on the subject in your textbook. And find some more problems to do on your own. Good idea. But try this one before you go. Come up with 2 answers. First, I want to reshape the equation with 0 on the right and everything else on the left. Then I get my two factors and solve each one as a linear equation on its own. Once again, my answers are both fractions, and they both work. You can count on it. And that means you're ready for two more methods of solving quadratic equations. The methods we've seen here are called square root and factoring. In other modules, you'll find completing the square and the quadratic formula. Look them up, and good luck.